All right, so we're doing lesson 9-1, and we'll look at problem number 8. So problem number 8 says a beetle sits on the top of a bicycle wheel with a diameter of 0.75 meters. So we're given the diameter is equal to 0.75 meters, which means that the radius is equal to 0.375 meters. Assuming the wheel turns counterclockwise, what is the angular displacement? So I want to find theta of the beetle before it is squashed under the wheel. What arc length does the beetle travel through before it is squashed? Okay. So, first of all, in order to conceptualize this, I'm going to kind of draw a picture. So the beetle is at the top, which is here. So here's the beetle. And don't forget that the wheel's going to turn, so it's turning counterclockwise, so a clock goes this way, so it's going to go this way. And then it says, so I want to know how far this goes before it's being squished. So it's going to be squished at the bottom, which is half the circle. So it's going to move to here. So where do we start? Well, we know that the circumference of a circle is the distance around it. So that's 2 pi r. So then how far it goes in meters is going to be half of that. So S is going to be pi r. So that comes out to be pi times 3.75. So S is equal to 1.18. Then we want to find theta. So theta is equal to S over R. So it's 1.18 meters over 0.375 meters. So it comes out to 3.14 radians. And that's it. So simple. All right, I'll do one more since that was only 2 minutes and 25 seconds. So I'll do number 11. Remember, 10 has A, B, C, and D. It says a figure skater begins spinning counterclockwise at an angular speed of 4 pi radians per second. Now, normally with rotational motion, our sign convention, just like we use the standard Cartesian sign convention and say up and to the right is positive, counterclockwise would be like this. So if you're in a engineering class and you're taking statics or dynamics, what you would do is you would draw your sign convention like this all the time. So you have up and to the right is positive and counterclockwise is positive. So in our given, we have that omega naught is equal to 4 pi radians per second during a 3-second interval, so delta t is equal to 3 seconds. She slowly pulls her arms inward and finally spins at 8 pi radians per second. So omega f is equal to 8 pi radians per second. And we'll do problems like this later on because this actually is conservation of angular momentum. What is her angular acceleration? So I want to find alpha during this time. So how do I know what equation to use? I'm given omega naught, I'm given t, I'm given omega f, and I want to find alpha. So we're going to say omega f is equal to omega naught plus alpha t. I'm going to rearrange the equation to solve for the unknown in terms of the known. So alpha is equal to omega f minus omega naught over t. So it's equal to 8 pi radians per second minus 4 radians per second all over 3 seconds. And alpha comes out to be 4.2 radians per second squared. And that's it.